Hey guys, if we take thionyl chloride and mix it with selenium dioxide taken in excess, then with the correct synthesis method we'll obtain a substance with one of the highest dissolving abilities among all known substances. I placed selenium dioxide in a flask with a reflux condenser in a calcium chloride tube, and in the other neck of the flask I insert a drop in thionyl, which I filled with thionyl chloride. Next, I slowly add thionyl chloride to the selenium dioxide. Selenium dioxide reacts with thionyl chloride to form dark red diselenium dichloride and selenium tetrachloride. Diselenium dichloride mixed with selenium tetrachloride can also be observed in the direct chlorination of selenium. As selenium tetrachloride is formed, the reaction mixture begins to gradually solidify, and in order to accelerate the formation of selenium oxydichloride, I melt this mixture. After adding all the thionyl chloride, the mixture must be refluxed for about 5 hours. Then, after cooling the reaction mixture, I pass dry chlorine through it, while the diselenium dichloride formed in the reaction, which causes the dark red color of our reaction mass, reacts with chlorine and turns into selenium tetrachloride, which in turn reacts with selenium dioxide to form the seleninyl chloride we need. When the contents in the flask acquire a pale yellow color, the passage of chlorine can be stopped, and the contents distilled in a vacuum or under reduced pressure, since when heated to the boiling point under normal conditions, seleninyl chloride decomposes. I'll do this under vacuum, that's why you can see how a capillary is inserted into the right neck of the flask. Quite quickly, selenium oxydichloride begins to distill, and a bright yellow liquid accumulates in the receiver flask. Which, after the second distillation, becomes less bright. This substance is pure seleninyl chloride. And when it cools down, it completely turns into a pale yellow liquid. If a test tube with this substance is placed in ice, it will freeze quite quickly, since its melting point is about 10 degrees Celsius. This substance is the best solvent for selenium and for other nonmetallic elements. It easily dissolves not only red but even grey, glassy selenium. At the same time, seleninyl chloride turns red. I'm not sure, but perhaps by evaporating this solution you can get red crystalline selenium. It's a pity that I only thought about this while editing this video. Selenium oxydichloride doesn't dissolve phosphorus, because white, red and violet phosphorus ignite upon contact with it. Pay attention to how in slow motion it's clearly visible how as a result of a reaction of selenium oxydichloride with white phosphorus, the vapors of a resulting red selenium are absorbed by selenium oxydichloride and it acquires a red color. It also easily dissolves sulfur, antimony, arsenic, iodine, and to a lesser extent, all other nonmetals, except silicon and boron. In any case, I wasn't able to notice a dissolution of these two elements, when all the others were dissolving at least a little. Most likely, carbon also doesn't dissolve, but I didn't conduct an experiment with it. Now let's compare the properties of seleninyl chloride with its closest relative, thionyl chloride. If you add a little water to thionyl chloride, it will immediately begin to hydrolyze, resulting in the formation of hydrogen chloride and sulfur dioxide. If you add water to selenium oxydichloride, the reaction will result in the formation of hydrochloric acid and selenious acid. Adding magnesium powder to the hydrolysis products causes a reaction with the formation of red selenium, hydrogen and magnesium salts. If you add magnesium powder to pure selenium oxydichloride, an equally violent reaction occurs, but with a slight delay. For the sake of beautiful slow-mo shots, I added a few drops of seleninyl chloride to the burning magnesium. If seleninyl chloride is added to a solution of silver nitrate, a precipitate of silver selenite and silver chloride instantly forms. You may know, but in laboratory practice, phenyl chloride is used to dry the hydrates of some chlorides. This way it can dry cobalt dichloride hexahydrate to monohydrate. Notice how after adding phenyl chloride to cobalt dichloride hexahydrate, it begins to boil. It reacts with the water of crystallization that is part of the salt structure. No such reaction is observed with selenium oxydichloride. Drying of chloride crystalline hydrates with phenyl chloride is one of the few endothermic chemical reactions. The temperature of this reaction can drop below 0 degrees Celsius. The temperature of the mixture with seleninyl chloride does not change. Now observe how different the reactions of anhydrous hydrazine are with phenyl chloride and seleninyl chloride. You can try to write the equations of these reactions in the comments. This is the same reaction, but in a test tube. Potassium explodes on contact with seleninyl chloride. So guys, I'm really glad I could share some insights about this fascinating organic compound with you. I was quite curious to explore its properties myself and showcase them here. Don't forget to leave your comments under the video, and if possible, consider becoming my patrons, as some of my viewers have already done. Your support really helps me create more content. Thanks for watching, see you in the next video.